Hello engineers, ladies and gentlemen. Welcome to another exciting tutorial. My name is Dele from DevOps Uncut. Today's tutorial promises to be really exciting because we shall be using a host of tools. This one from the DevOps toolchain. We shall be using AWS as our cloud provider. We shall be using infrastructure as code Terraform to provision infrastructure and our resources. We shall be also using Terraform to create and provision a Kubernetes cluster in AWS Cloud. We shall be creating a Dockerfile, create a Docker image, and pushing that image to Dockerhub to be used later on by our deployment. And then we shall deploy our container, our containerized application in a Kubernetes cluster. And then finally, we shall access our cluster using a load balancer service. So sit back and relax, and I shall see you at the terminal. So here are the steps we shall be taking in this project. Our aim today is to deploy a web application, a container in an EKS cluster, which is a Kubernetes cluster. Now, these are the steps we shall take. Number one, we shall create a remote backend so that we can store our state files remotely. We shall be using an S3 bucket and a DynamoDB table for locking. Now, this will be done using Terraform. After we create our remote backend, we shall begin to create our main infrastructure. This will include a VPC. We shall create subnets, 2 private and 2 public subnets in 2 different availability zones. We shall create an internet gateway, a NAT gateway. We shall create route tables, route table associations for our subnets and gateways. We shall create security groups for our Kubernetes cluster and for a Bastion host. And we shall create a Bastion host in a public subnet, in one of our public subnets, and allow SSH and downloads. Then we shall create a Kubernetes cluster, EKS cluster in our VPC, also using Terraform. So after doing this, now our application will be, initially will be a HTML website. So we shall create a Dockerfile and create a Docker image for our application. Once we've created the Docker image with application, we shall push the Docker image to Dockerhub. The next step will be our deployment. So we have our manifest files, we shall create a deployment and then create a service to expose our deployment. Our deployment will pull our image from Dockerhub and deploy this as a container, as a pod in a Kubernetes cluster. And then our service, which is of type load balancer, will be used to expose our application. And we shall access our application from our internet browser using the load balancer's internal IP. Yes, so that's the plan for today. So let's get started. Okay, so the first thing we need to do is set up our remote backend, which is we shall be storing our state files remotely in an S3 bucket and locking this with DynamoDB. So all the files I need are in this S3 files. I put them here, and let's go into this. Let's see, S3 for the folder, and let's list. You can see here the 3 files: main.tf, provider.tf, and available.tf. Now, what we want to do here in this is that we need to create an S3 bucket, and then we need to enable versioning for the buckets, and then we need to enable server-side encryption by default to make this secure, and then we need to create a DynamoDB table, which we shall use for locking. So 34 things we need to create. So let's begin to do this. So before we create our infrastructure, let's have a look just to verify that we haven't created an S3 bucket or a DynamoDB table yet. So let's go there. S3 buckets. There should be nothing there at the moment. We're going to create this programmatically using infrastructure as code. We shall use Terraform to achieve this. So let's check Amazon S3 buckets. Let's try to get this out. Let's go to buckets. Loading. Let's see. As you see here, it says you don't have any buckets. So we have no buckets as of yet. Next, we shall have a look at DynamoDB to see if we have any tables created. So go down DynamoDB. Let's click on that. This also will be created using infrastructure as code, Terraform, just to verify there's nothing there now. Let's have a look at this. Okay, let's check again. Tables. There should be nothing there. See, you have no tables in this account. So no tables. So we're going to create a S3 bucket to store our Terraform state files. We shall enforce table locking using DynamoDB, and we shall store our Terraform state files. We shall configure our Terraform to store state files in this remote backend. So the first thing we need to do here is to set up our provider. So let us go to our provider.tf file. Our provider will be AWS, and the region I have chosen is US East 1, but you can choose any region you prefer. So here provider, you can see AWS, and region is US East 1. So now we have a provider, we can now begin to build our main files. We shall use main.tf to build the main files. So next, we shall begin to create our resources. So let's start. I've already put the files in there. So let's go to main.tf, and we shall begin. First thing is to create our S3 buckets. And there you can see that we have named it DevOps Uncut Remote Backend. So we create the S3 bucket here. Next, we enable versioning here. Versioning of our buckets again. Same bucket, DevOps Uncut Remote Backend. Status enabled. After that, we shall enable server-side encryption by default. If you go down, you can see we have done this here for our buckets. Let's apply by default, algorithm, AES 256. And then also we shall create a DynamoDB table. We've called it Terraform State Locking. We have now hash keys lock ID, attribute name lock ID. This is important. You must set this, or else you will not be able to, it will malfunction. You'll not be able to perform state locking with your Terraform state files. Okay, so this is all we need to do for the resources we need to create. Okay, and then now I do not like the way it is looking right now because we have used the bucket name a few times. Yeah, I like to use variables for enable code reuse, and it's just a cleaner, smarter way to do things. So we have our variables.tf file here. So now what I'm going to do here is I'm going to change a few things. I'm going to change a few things. Hold on a second, please. So now let's begin to use variables. We don't want to hard code this anymore. So because we used this name a few times, so let's just do var dot bucket name. Sorry, var dot bucket name. Okay, so now that's going to be the name of a bucket, and this will be the value. Okay, so that too, let me just copy this. We use this 3 times. So copy. So also with this is going to be var dot bucket name, and then var dot bucket name. Okay. Yes. So and then we'll go to hold on, and let's also change this to the DynamoDB table. Let's just make this also var dot DynamoDB underscore table. So we have bucket name. No, not DB name. DB the name. That's the name. Not DB name. That's the name of our DynamoDB table and name of our Terraform bucket. Okay. Yes, that is fine. So let's begin. Let's fix the variables. So we are going to put default values for our variables. We now have 2 variables: variable bucket name and variable DynamoDB name. We want to call our bucket DevOps on COTS, remote backend, and we call our DynamoDB table DevOps on COTS, DynamoDB table. So just for easy identification. Okay. So let me do that now. Okay. So go to variables.tf, and there we declare that bucket name variable and the DynamoDB name bucket name, and no, it's underscores. Avoid errors. Underscores. Let me check this. Make sure I'm right. Yes, they're underscores. So yes, this is DevOps and COTS. So we've created these 2 variables, and also our provider. Yes, let's make this a variable too. We call this var dot region. Let's do the back, and then quickly back here. Let's do variable. Yes, so it's region and default is equal to this. Yes, that's what we've got to do. I guess that's fine. So now it's time to actually begin to create our infrastructure. Now, okay, so we need to go to the folder where S3 files folder, which is where all the files reside. So let's go to S3, this tab, okay. So I'm into that folder, and I shall run Terraform init now to initialize plugins, any modules, and the backend. So the backend, so provider plugins, AWS, let's do what it needs to do. Initialize, hopefully successfully. So this is we're just preparing the remote backend. That's why we're in the S3 files. We're running only the code. Something, just let's relax and wait for it to finish. Find the latest version of, the provider. Initializing the backend. I can see it's doing something on the left. So you can see it's created the .terraform file, which contains those that information, the plugins, models. Okay, it's been successful. So we have done the first part. So now let's do a Terraform validate. I like to do this. It's optional, but it will find any syntactical errors, just minor problems. Let's run Terraform validate. And it's optional, but I like to do this. That's part of my again, yeah, there it is. Success. The configuration is. So now we're going to do a Terraform plan. That's a dry run. So let's do Terraform plan. Show us the resources that will be created. I'm expecting 4. The S3 bucket, the DynamoDB table, a resource for to enable versioning, the third, and the final one is to enable server-side encryption in our S3 bucket. Yes, that's it. 4 there. Let's go through the 4. It's going to create a DynamoDB table. You can see DynamoDB table. Going to create an S3 bucket. It's going to create a server-side encryption. It's going to enable that, and as I said, it's going to enable versioning. So that we have 4 things to be created. 4 things to be created. Now we're going to actually create the resources. Let's move this up. We're going to apply everything now. So let me just clear screen and let's type in Terraform apply. I will use the auto approve option, the flag, because it helps us to auto approve, so it doesn't ask us whether or not we want to go on with the application. Okay, so Terraform apply is in process. It is creating. This will go connect to the AWS API to our cloud account and the customer account, and it's going to start creating. So it's telling you plans to do 4. It will go on. Now it's beginning to create. It's creating the S3 bucket. You can see DynamoDB table is being created. Encryption is being created. Yes, apply complete. Resources 4 added, 0 changed, 0 destroyed. Terraform has cleverly executed our code configuration. So now let us go into AWS console and see if Terraform created the S3 bucket and the DynamoDB table, which we need to store our state files. Okay. So let's go there. Let's check S3 first of all. S3 buckets. We call it DevOps and cuts, remote locking and stuff like that. Let's see. There it is, remote backend. There we have S3 buckets. You can see there it has been created. That's S3 buckets. Brilliant. So now let's go back and we need to check if our DynamoDB table has been created. That we also call DevOps and cuts. I think it's DynamoDB table, something. Okay, so let's go into tables. Let's click on tables here. Yes, there you can see DevOps and cuts, Terraform login. That's a table. So we have created these 2 resources in the customer account in the cloud using Terraform. So now we're ready to now build the main infrastructure and store our state files in S3, in an S3 bucket remotely. Now we have set up our remote backend. It is time to start creating our infrastructure. So we shall start, close this. So we're back to our root. We shall start with the provider.tf, where we declare our provider, which is AWS, so we can begin to create our files. We shall also include backend, because we have now done we set up our remote backend, so now we shall include it. We shall include that here in the provider .tf file. So there we are. So you can see provider AWS region US East 1, what I usually use. You can use any region close to you. You know, if that's best for you to help with latency. Okay. Yes, so you can see here Terraform block. I've declared my backend here, and the settings, my buckets, DevOps on cut remote backend. Remember we did this earlier. Terraform. Also, the table we'll be using for locking. I've also put it there. DevOps on cut Terraform locking. So this is all we need to set up our provider. So next, let me save this, and next we shall begin with our main configuration, where we declare a networking.tf, we should declare our VPC and networking with the subnets, route tables, routes, and all that. So get ready as we begin with the next stage, which is to create our VPC and the networking. Now we shall begin to create our main files. We should start with the networking.tf, and this I'll show you. I've already done that. I'll just explain through. Here we created our VPC, the subnets, 2 private subnets, 2 public subnets. We create an internet gateway public subnet to create a NAT gateway public subnet to be used by the private subnets. We did the route tables, and then later on I'll explain the concept of modules. I use modules to create our Kubernetes cluster, EKS cluster, and the cluster security group. I will explain this later. So let's look at the code. Networking.tf. First thing you'll see is the VPC. That's VPC we created. We called it ACME VPC. And then next, create 4 subnets, 2 public and 2 private subnets. They are now, the subnets will be created in 2 different availability zones. Okay, so I've called them AZ1, AZ2, and set them as variables. Okay, so we created public subnet 1. That's a CIDR for that. Created public subnet 2 in another AZ2. Then private subnet 1, that's an AZ1. Private subnet 2 in AZ2. So we have 1 private and 1 public subnet in each of the availability zones. So I'll show you later. I use the variable, but they're actually US East 1A and US East 1B. Then I created the internet gateway, and then the route table, the destination, everywhere, targets is an internet gateway, and then it was associated with a public subnet. So allow resources in the public subnet to reach the internet. And then we need to create an elastic IP. So yeah, then now we created 2 route table associations. That's because we have 2 public subnets now. Okay, and you can't use the same name. So one subnet has been, so this is the first subnet, that's the second subnet. You can see subnet 1 and subnet 2. So those 2 public subnets are associated with the internet gateway. Yes. Next, we have to declare an elastic IP because we want to use a NAT gateway. We shall create the NAT gateway, the public subnet, one of the public subnets, here public subnet 2, but then it is to be used by the private subnets to access the internet. So you see the route tables, private route table, the gateway ID, gateway is the NAT gateway ID. Okay, so you can see that's the yes. So yes, and then you can see the route table association. We have associated the private route tables, the private subnets, with the NAT gateway, which is in the public subnet. Okay, so that is it. And then the models below are for the cluster. I'll come back to this later. I'll come back to this later and explain what I've actually done there. Next, we shall create our Bastion, which is just an EC2. Really, we could do a Bastion in one of the public subnets, and we shall open up port 22 so that we can SSH into the Bastion from remotely, and also allow ingress to allow download of patches and software. So let us begin. That's the Bastion TF, you can see. So the first thing here is that we are going to use, for an AMI, we're going to use AWS data source. That means it will look for an AMI that satisfies the conditions, the filters I have set. So it's going to look for an AMI that has this string in its name, and one that has a virtualization type of HVM, and which the owner corresponds to this. Now this is an Amazon account number, so it's going to look for an AMI owned by Amazon and satisfies the other filters, and then it will return the most recent. So just one, most recent is equal to true. So that's what we should use for the AMI for our Bastion, our EC2 instance. Now for our key pair, the key pair will be used also for SSH. Now we're using a key pair that already exists. I've already set one. It's already in AWS account, and the private key is already on my local machine. So there, so another data source, AWS key pair. So we just named it the existing pair, and we've assigned the value of key name to my EC2 key pair, which is the name of the key pair that I've already had in AWS. So I want to use that key pair. And when we now define our resource, the instance itself, we shall use that key pair in its configuration. So our AMI is the data source AMI that has been retrieved. This is it. Okay. You can see here we had it there, data AWS AMI Ubuntu, and this is here. The ID of what it has returned will be in here. So we shall have one AMI that satisfies those conditions set in the filter. Now the key name is here. You can see the key name. Oh, sorry about that. Go back. Now the key name here. Oh, I just keep doing this. The key name here is what we set at the top here. You can see the data AWS key pair existing key pair dot key name. Instance type, we shall use for this purpose small size. We shall use the T2 micro. We'll set this in the variables.tf. Associate public IP address is equal to true. We want our instance to have a public IP address so we can access it using the public IP address. The subnets. Now we want to create it in just one of the public subnets. So I've selected public subnet 1, AWS public subnet 1. This is one of the subnets we created earlier on. We had public subnet 1 and public subnet 2. That's the ID in there. And then the VPC security group. It's a security group called ACMSG security group. Now I will show you that's our security.tf. You'll see ACMSG. This is the security group we're going to use. And also, it's for this VPC, you can see. And we've opened port 22 ingress to allow SSH from anywhere. Normally, we'll restrict to your IP address or read IP address of your team. So don't do this in production. And then allow egress to download patches and software. So the Bastion, we'll use the security group. It's in the public subnet, public 1, we call it Bastion instance, and we use the key pair already created, and also the AMI we've retrieved from the data source. So that is all for our Bastion. We shall now create the security group for Bastion. We want to open up port 22, ingress, and also egress to allow downloads and installations if needed. So straight away, let's go to, we have it there already, security.tf, that's for our Bastion. And you can see ACME SG is our Bastion, which we referenced earlier. So Bastion security group, which we referenced in our Bastion creation earlier. This is the Bastion. Here you can see the security group was ACME_SG. Yeah, so this is the security group here itself. What we've done, it's in our VPC as well. You can see that, and then the security group rules. So we have port 22 for SSH access, and then that's the ingress, and then we've done another egress this way to allow our Bastion to reach the internet in case it needs to download patches or any other installations. And the security group you can see is the security group of our Bastion. So that's it for the Bastion security group. Next, we shall begin with our Kubernetes cluster, EKS cluster. So before we go into the cluster creation, I need to explain the concept of modules to you because I have used modules in this demonstration. Now you will see that our main files for Terraform infrastructure are in networking.tf. This is where we did all the VPC, here the VPC, the subnets and route tables, everything else. But at the bottom, you will see that I declared two modules. Module SGS, that's a module for the cluster security group, and module EKS is the module for the cluster. And if you see the source, I referenced two folders, EKSG and EKS. So if you look to your left, you will see EKSG there and EKS. So what I did was I put the configuration, the code to create this cluster and security group in separate folders, in these modules, and then on the main networking file, I will call those modules from there and pass in the parameters required. So that way you can reuse those modules by passing in different parameters. This helps to reduce code duplication, or as well as code helps with code reuse. It's a very efficient way to write code these days. So let's go into first of all the EKS first of all, so you understand what this really means. So I'll go into the EKS folder first, which contains the files for this module. So let's go into the EKS folder, EKS module, and see what's in it. So click on the EKS module, and then you'll see I've got 4 files in here. The EKS clusters, that will be the code cluster. The EKS roles will contain the code for the cluster and what kind of roles. Then outputs, which outputs things we want to output to our local machine after execution, and then our variables. So now with EKS, with the clusters, you need to create the roles before the clusters. So let's start with the EKS roles. So first of all, we're going to EKS roles.tf. Now you can see I've defined the first AWS IAM role. That's a cluster role. So that's a cluster role, and then you will see below the policies we need. Now we need just one main policy, and that's the Amazon EKS cluster policy. So this resource, we create this policy, and you will see right here, that's the role. We're going to assign this policy to the role we create up there. So we create one role that it has the assume role policy. It assumes the role, and we shall assign this policy to that role. Okay, and if later on we shall, assign that policy to the cluster, to the our user. So next, we have to define another role for the worker nodes. Okay, that's the worker nodes. So here again, assume role policy, and then this would need 3 different policies. It needs the Amazon EKS worker node policy. Also need the Amazon EKS CNI underscore policy, that's for the networking, and also Amazon EC2 container registry read only. It needs that for containerization, be able to read and control containers, or access to ECS. So we need these 3 policies for our worker nodes, and you can see we've assigned each one to the worker node role above. So in a nutshell, these are the roles. We've created the roles, one for the cluster, one for the worker nodes, and then we have assigned the policies to them, and that's all we need so far for the roles. So this will create the roles we need to create the clusters. Now that we have our roles and our policies attached, we can now begin to create our EKS clusters. Okay, so let's go to EKS clusters and see what we've done so far. Okay, now first is, you can see the first resource is to define the cluster. We've called my EKS cluster, and the first thing I did was to assign the cluster role we created earlier. That's the cluster role. Remember, you have to do that. Then the VPC config. Here we're going to configure the subnets in which this will be created. So the subnets, it's like in angle brackets. It's an array, a list type, and there are 2 variables: subnet ID, IDs, and the index is 0 or 1. So therefore, we can pass 2 subnet IDs into this at runtime. Now, I call them subnet IDs. That's the variable name. If you go to variables here, variables in this, you will see that it is a list type. Now, we have not given a default value for this. You know why? Because we're going to pass those values from our model. So now if you go to our model we had before, I showed you earlier on in networking.tf, EKS, you can see subnet IDs there. And we're passing the subnet IDs of our public subnet 1 ID and public subnet 2 ID. So these 2 IDs are what will be, we shall be using here. That is what will be passed into our cluster here as variable subnet ID 0 and subnet IDs 1. So that's the beauty of using models and variables, because we're going to pass the variables at runtime. So that means anybody can use these models. They can just pass in whatever subnet they want and it will work. Okay, so then you see it depends. Here we have a depends on meta argument. So this ensures that our roles are created and the policy is created before the cluster is created. So this cluster resource depends on these roles. That ensures that there are no hiccups, and this is created before the cluster. Okay, so that's the cluster. Now we need to create the resource for the node group. That's about worker nodes. Okay, here, so that's the resource for the node group there. Belongs to a cluster. You can see the cluster name, part of our cluster. And now we call it my node group. That's the node group name. Now look at the role. We've assigned the role we created earlier for the worker nodes. Yes. Now, the scaling config, we have desired size 2, max size 3, minimum size 2. What we are doing here is we want to create 2 nodes, but we have a maximum of 3, which means if we need more nodes, auto-scaling will kick in and automatically create another node. So it can upscale as well, and it can downscale. That's where the auto-scaling comes in from. And how we have update config max unavailable is equal to 1. What this means that when it's upscaling, always, or when it's downscaling, always make sure that there's not more than 1 available. Okay. Instant type T2 micro. Now remote access. That is for the SSH key pair, which we created earlier, and it ensures that this is the key pair we used for SSH. We created earlier on. And you can see the security group, SGID. This is the security group that we created earlier, if you remember. Security group for our Bastion. As SGID, let's go back to that. Hold on, let me go to the SGID. Hold on, let me see. It's a variable. This is SGID. SGID is the security group for our cluster. What's going to happen is that you see now it's type string, but we haven't assigned a security group. This will be done at runtime. So if we go to our modules again, this time, let's go to back to the modules there. That's with .tf. And you will see here, SGID here has been declared. So you can see it's module. So it's going to go into our security group, which is there, and find the output, which is security group public. So let's go to SGS, which is an EKSSG there, EKSSG here. Outputs, you can see security group public, and that's the worker node security group. So that we passed in also at runtime. That's how modules work as well. So back to the cluster. So the security group passing at runtime, and so with the subnets. So for the worker nodes, that's you can see that the variable, we have a variable subnet IDs, variable for security group as well. Okay, so let's go back to our model networking. You will see we have subnet ID and security group ID passed in. So that means we can use any ID for these things. We can change the parameters and reuse the same model for different purposes. Okay, so let's continue with this. So that is all for this security group. You can see that now the worker node depends on these 3 policies I've said before. We want to make sure these policies are created before the worker node is created. Okay. Yes, so here we have just a recap. We created the EKS cluster, and then we created the worker node, the node group, configured the node group, and then we created variables. And the variables we passed in from into our model in our main file. So there you can see we'll pass in the VPC ID, which is just the VPC ID, then subnet ID, the list will be from passed in there, and then the security group IDs. So that's all we need to know for this. And remember the module as well as security group. This will just be fine because everything we need. We didn't need to pass any variables here except the VPC ID. Okay, let's go into that. Let's go into the cluster security group. There's a cluster security group. Okay, so this is for the worker nodes. You can see we're allowed ingress port 22 and egress. There are really no variables to pass into it except the VPC ID, But the outputs, the security group, when it's created, the ID will be output as this variable, security group public, which is what we used in our model there. So that's all we needed really for our EKS security group. So, well, all this, I'll put the source code of all this in my GitHub account so you can follow along. You can grab the source code and use in your own projects, because I know it might be difficult for you to pick what I'm saying here, but you would also make sure I upload this to my GitHub account, and then you can go there and use those files or modify them for your own purpose. Okay, so that's the completion of our cluster. This is the files, we have all this, we've gone through all this, and also the security group for the cluster. The working notes also there. So that's what we have so far. Okay. So now that we have we're choosing the files to create our infrastructure, main infrastructure, and also our EKS Kubernetes cluster and working notes. Let's now begin to create, and let's see how that goes. I know this is where it gets interesting because we might have errors come up every now and then, but that's the joy of DevOps. You have to know how to deal with errors and troubleshoot and solve them. So I will begin by running Terraform init which will initialize my working directory. It will download plugins, provider plugins, to initialize the models and our backend as well. Okay, so let's go Terraform init. It will acquire the state locking. Let's see. Let's go. So initializing the backend. So initializing. Okay, it says configure the backend. Initializing models, as I said. Next, the provider plugins, as expected. Okay, no errors yet. Let's keep our fingers crossed. Pray for the best. Okay, it's initializing. This shouldn't take too long. Okay. Look at the models part. EKS in EKS. I mean, it went into the source in the EKS folder, and it went into the model SGS in the EKSG folder. So it's looked at, okay. It has been initialized successfully, so that's brilliant. Now let's be clear and let's validate this. As I always say, this is optional to validate, but it's a habit I have picked up over time because it just helps you to check for syntax errors in your Terraform configuration. Okay, but you can skip it, but I just like to do that. So Terraform validate, it's going to check the code to see any little minor syntax errors. It could be, okay, success, it is valid. Yeah, the warning just means that this part is being duplicated. It's going to work, but just that means it's reached its end and you can use another attribute instead. Okay, so that was fine. So it is validated. Now we shall plan. Do a plan, and then finally an apply. So let's now go. And let me clear this first of all. Let's clear. So we can see what is going on. And I will now do my dry run, Terraform. This will show us what will be created. I would say we'll probably have about 20, like 27, 28 resources created this time. Let's see. Okay, Terraform plan. Let's see if this goes okay. Even though it's acquiring state lock, yeah, so it is connected to our remote backend, the S3 bucket. It's acquiring the state lock from the DynamoDB table. Okay, now it's creating infrastructure. Okay, now it's finished the plan. Let's see what it's planning. Yeah, you can see it's planning to create 27 resources. I'm going to create all the infrastructure, VPC, subnets, all those things. I'm going to create also our cluster, create the node groups, security groups, all those things. Now, next, we're going to now run, apply. Now it's time to actually create our resources, our 27 resources. So let me clear the screen again to better view it. Let me see, let's clear that. Okay, now I will run. As usual, I will use the auto approve flag so that Terraform does not prompt us to agree to continue or not. It will just by default select yes on our behalf. Use this with caution. So Terraform apply, auto approve. Now let's go and let's watch our resources being created. Ready state lock again. It's once it acquires the lock, nobody else can work on that. A configuration until the state lock has been released. Okay. Now it's beginning to tell us it's planned 27. Now it's going to start creating. Okay. It's creating the EKS, creating the IP, Elastic IP, it's creating the subnets, it's creating route tables, internet gateway, you can see the NAT gateway. It's now creating our models. So now I'm executing on the models, creating our clusters. Worker nodes, you can see, yes, creating our Bastion, double instance Bastion. So it's doing something now. Yes. The thing is, sometimes this could take up to 50 minutes sometimes because cluster creation does take a bit long. So we might have to maybe pause this there and come back near completion because this, we'll be here all day waiting for this to finish. Okay, cluster have been created. That's brilliant. Now it's just doing the node group. It won't take as long as the cluster. The cluster is always the longest. The cluster itself took 11 minutes, 31 seconds, 41 seconds to create. 11 minutes, 41 seconds. That's how long it took the cluster to get created. Let's see how long it will take the node group. It will be a lot less than that, for sure. Two nodes and in two availability zones. So it will auto scale if there's a need to have more than two nodes. To auto scale. So now we're just waiting for the node groups to be created. 1 minute 40 seconds, 1 minute 50. Yes, it's created. The notebook took only that, and there apply complete. Finished, everything is created, 27 resources. The node group took less than 2 minutes, so you can see that the cluster itself takes some time. Now we have created all our infrastructure, so it's time to get to the deployment part. Now we're going to use EKS. We're going to use kubectl to deploy our application. kubectl is a command line tool used to interact with a Kubernetes cluster. Now, so here, what we're going to do here is that we have our HTML website, but what we're going to do, we're going to create a Docker image of this website, and we shall push the website to Dockerhub so that our deployment, the image, creates our deployment, a container, and deploy in the EKS cluster. So let's go on. I will show you quickly how to create this Docker image from our web page. But understand that this is not a Docker tutorial. So you need to, if you don't know about Docker, then you probably need to go and read about Docker and then come back later to this, because then you understand what is going on. So let's start with that. Okay. So now I will create a folder, new folder that will contain our application, our web application. So let me make a new directory. Call that website. Okay. Now inside this website, hold on. Inside this website, let me just navigate there. I will create two files. Index.html, which will contain our index file for a web page, and then I'll create a Dockerfile, which I use to create our Docker image from this HTML image. So let's run that. So now on the left, you can see we now have a website here, and open that. We have a Dockerfile and index file. Okay. So I already have the code for our web page. So I'm going to paste that into our index.html. Okay, so I'll paste that into our index.html there. Hold on, let me do HTML there. And this will be the code for our website. So there it is, simple web page. Just says double quotes. And how to deploy a web page in a Kubernetes cluster. That's all, okay. And then, let me save this. Then we shall write our Dockerfile. Okay. I'm going to use an Nginx base image for this. So if you don't know how to write Docker files as well, I guess you go and learn a bit of Docker. Okay. So I'll start. We'll use the basic. Use the Nginx as our base image. Every Docker file needs to have a base image upon which to build everything else. So we're going to have an Nginx here as the base image. Okay, so we use the from clause to get in. So we're going to need Nginx, the type of Python outputs there. So this is going to specify that we need to use Nginx for the base image. So the next thing is we need to do is to copy our HTML file to the Nginx web root directory. Okay, so let me just hold on 1 second, please. So what's it next? Copy to Nginx root directory. So this way we shall be able to serve our web page. Okay. So what we're copying is the HTML file. So copy HTML file. Let me explain this. Copy HTML file to Nginx root directory. Okay, to the Nginx root directory. Once we copy that, that's our Docker image to the Nginx. Okay. Now Nginx's root directory is always in the user/share Nginx HTML folder. So let me just put this here now. Okay, hold on. Yes. So this will copy our index HTML file here, which we already have here. We'll copy this into our Dockerfile, and from this we shall run a few Docker commands to create a Docker image, and we shall push this image to Dockerhub. So that is, so far we have that. Now, so now we have our Dockerfile and our web file, HTML file created and ready to go. So now we have created we have our index HTML file, a Docker file, and now it's time to create our Docker image. So let me just clear the screen so we can do this. So the first thing is we're going to build our Docker image. So at this point, if you're working from your local machine, you need to have probably like Docker desktop run in the background, because you cannot build images and containers without Docker desktop or something, or Docker, without the Docker engine running. So I have mine running already. Okay. So first thing is to build our image. So Docker build command, tag our image. Okay, so you need to tag it. Since I'm pushing Dockerhub, you need to tag it with your username. This is my Dockerhub username. And then you want to put the name of the image you are building. I'm going to call mine, let me say, DevOps Uncut web page. Okay, so let's also say DevOps Uncut web page. Remember that. It's versioning, okay, and then the dot. That just means copy everything from there. So I'm going to copy when we run it and basically run everything, all the files there, and copy into this image. Copy everything to this image. So let's go. So I'll run that now. And we'll see. So it's building. You can see Docker is building that image. So my image is being built at the moment. Yes. It's building the image. So it's from Docker. It's downloaded from Docker. The Nginx it needs. So it works like in layers. Once it's installed, it's got all workings from Nginx, then it will copy to the root directory we need, and our image will be ready. This shouldn't take too long because it's a very lightweight Docker image. Yes, so it's written an image. Okay, so let's just check and see if it comes up. Sorry, let me just go Docker images. So just to see Docker images. Let's see. Yeah, I've got so many images here. You can see. Yes, but let's just look for the one we want. We're at the top probably. Just notice all the images I have created. Quite a lot. So you can see this is what we just did. The DevOps Uncut webpage. So we do have an image there. So that's fine. So I've created a Docker image. Let me clear this. Okay. Now we need to push this image to Dockerhub so that our deployment can pull it later to create our deployment. Okay, so let's log into Docker first. We need to do Docker login. So you need to have a Dockerhub account first of all to do this. So Docker login, authenticating the existing credentials. It's logging into Docker. Login succeeded. So when I've logged into Docker, I need to push my image into Dockerhub. Okay, so run Docker push, and then my image again is daily / now what did I call it again? Do you remember? What did I call it again? It was DevOps Uncut webpage. DevOps Uncut page. Yes. Latest. DevOps Uncut webpage. Latest. Okay, so let's push that to Dockerhub. It's pushing, preparing, waiting. So you can see what we've done here. We created a file, a Dockerfile. We had a web page. We now created a Docker image from the web page and Dockerfile, and that image now we've just pushed to Dockerhub, which is a repository, because we shall need that image later when we're running kubectl, when we're deploying our manifest files for our Kubernetes cluster. So next, I will show you our image that has been pushed to Dockerhub. We shall go to Dockerhub and look at the image. Now that we have created our Docker image, we have pushed this also to Dockerhub. So now I will go to my Dockerhub just to show you that the image should be there by now. So let me just go to my Dockerhub. So that's dockerhub.com. Already logged in, so it should just take me right in. Dockerhub.com. Yes, taking me to my my Docker account. Loading. Hold on. Okay, yes. And right here, see that? You can see DevOps Uncut web page pushed 11 minutes ago. So yes, you can see that that was successful. We have successfully pushed our Docker image that we created to Dockerhub to be utilized by our deployment later on in the final stage, where we're deploying our container to our Kubernetes cluster as EKS on AWS. So brilliant. So you've done well so far. Thanks for sticking with this tutorial, and we're almost there. It's just one more step, and we should be able to view our web page in our cluster. Okay. So next, we shall be going next. We'll go to and begin the deployment process, where we shall use kubectl to interact with our Kubernetes cluster. So now let us check to see if our cluster is actually up and running. We have created our infrastructure, including the cluster. So we can do this using kubectl utility. You have to have kubectl installed. If you don't have it, you need to do that now. So kubectl get nodes. Now, if you remember, if you go, let me just scroll it down. If you go into our EKS cluster, the worker nodes, the node group, you see that our desired size is 2. Max size is 3. That is 2. So that is why we are doing this. So we should have created 2 nodes, which is the default desired 2 nodes. Let's still get nodes. And wait for that. Yes, you can see we have 2 nodes already there. Now let's see if we have any containers running, any pods in our cluster. We should have none right now because we haven't deployed our application yet. kubectl get pods. There have been no resources, I bet, because we have not deployed. Yes, okay, no resources found in the default namespace. That's correct, and that's fine. So now our Docker image is currently hosted in Dockerhub. Now let's have a close look at our manifest files, which includes, it contains the 2 files, the deployment.yaml and the sub.yaml, which we shall use. Now, deployment.yaml will do our deployment into our cluster, and the service.yaml will expose our deployment so that we can view it from the internet. So let's look at deployment.yaml. See its kind deployment. Now, it says match labels, app, web app. Then our labels here, template, app, web app. Okay. Now, here's our container. And you can see the container image. And this is actually our Docker image, hosted in, if you remember, hosted in Dockerhub, DynamoDB/DevOps Uncut webpage latest. So when a container port is port 80, which is HTTP port, to view from the internet. So when we deploy this, it's going to create 2 replicas. Okay, 2 replicas. So we're going to have a 2 replicas of the same, of our. We're going to have 2 copies of our application running on 2 different nodes. Okay. So now at this stage, we really can't view this. We need to use a service. So we shall now deploy a service as well, and the service will link to this deployment by using this label app web app. It's to look for the service that has this value and its attributes. So next we have the service.yaml, kind service, selector, you see app web app. So it's going to select our deployment because of this line here. Okay. Now it's a type load balancer. So this is a load balancer service. A port 80, target port 80, HTTP. So this load balancer will help to expose our deployment. And so once we've applied the deployment and the service, we can view our deployment using the IP address or DNS of our load balancer service. I will show you how to do this. So that's what we need to know for now. And now let's begin to do our deployment. Okay. Now let us begin to do our deployments. Okay. So, let me just go to the right, hold on, I need to be in the right folder, manifest folder. So cd manifests, yes. Okay, so let me just list, make sure I'm there, where our files are. List. As you can see, permitted YAML, service.yaml. So I'm in the right place. Okay. Let's move this up. Okay. Let me just clear this instead. Hold on, sorry about that. What's happened? Let me clear this completely. Okay. So, there's a cube CTL. Apply, that's the command. Option -F. And then deployment dot YAML. Now this should go grab a container from Dockerhub and deploy it into a cluster. So there we go. Working. That's why it's doing nothing yet. Yes, deployment created. Okay. Now let's do this now. We need to deploy our service to expose it. So cube CTL apply -F and service dot YAML. And let's go. Created. Okay, so now let's just list our deployment to see if it's created. So kubectl get deployment. There is our deployment, web app deployment deployed. So let's see if we have any pods running now. So let's do a kubectl get pods. Remember, we just had nodes before, no pods. Kubectl get pods, which have 2 pods running now. Let's see. We'll get pods. Waiting for, yes, the 2 pods. You can see they're running there. They're both running there. That's running there. So everything's looking good. Okay. So now we need to check our service and grab its load balancer, which we shall use to access our deployment via the internet browser. So kubectl get service. You can type either the full service, or you can just type a shortcut SVC. Same thing as service. Get service. And we should see our web app service and the load balancer IP. Yes. So there you can see the external IP. There's external IP there. That's the cluster IP. So this is what we need. The external IP is what we shall use, the load balancer IP, to access our deployments. Let me copy this. Okay, so next we shall go to our browser and try and access our deployment using this IP, the external IP of our load balancer. Okay, let's hope everything goes fine, and I'll see you at the browser. I have copied the external IP of our load balancer. So now I'm going to go to here. I'm going to run the IP address, and if everything has gone well, we should see our application in the internet browser. So drum roll. This is a big moment of truth, to see whether or not all this has been successful. So do HTTP, and let's post the that's our load balancer just there. So drum roll, enter, and hopefully we shall see our application has been deployed into our Kubernetes cluster. There we go. Yes, successful. So, ladies and gentlemen, we have successfully deployed web application as a container in our EKS cluster, in our Kubernetes cluster. So thanks, ladies and gentlemen. I hope you enjoyed this. Please don't forget to subscribe to my channel, share, and like. In the next video, I'm going to introduce the concept of CI/CD, continuous integration, continuous delivery, deployment. This time, we're going to do this whole process. We're going to automate it using a CI/CD pipeline. So we shall introduce Jenkins in the next tutorial.